Hello, today we're going to be learning about the Polygon Sum Theorem. Before we progress with the lesson, just a quick reminder that you can pause and rewind this video at any point to see anything that you missed. Okay. So without further ado, let's go ahead and start looking at the first table that we have here. Before we can apply the Polygon Sum Theorem, it would be helpful to know what the names of the polygons are. The smallest polygon you can have is a three-sided figure. And there are infinitely many polygons. However, I'm only going to require you to know the names up to 12-sided figures. Okay. So most of these you probably are familiar with. Some of them probably need a little bit of memorization. But a three-sided figure in general is called a triangle. Okay, it's the most basic one. There's several different types of triangles, but we're just going to call it a triangle for now. We're just talking about the general terms. Four-sided figure, quadrilateral. So again, there are very specific four-sided figures like a square, a rhombus, a parallelogram, trapezoid, but we're going to again refer to them in their generic terms, the general terms. Five-sided figure, pentagon. A very famous example of that, of course, is our government building called the Pentagon in Washington, D.C. It's called that for a reason. It has 5 different sides. It's in the shape of a pentagon. Six-sided figure, hexagon. A seven-sided figure is probably one that you're not familiar with, and there's actually 2 terms for it. I generally go with the heptagon, H-E-P-T-A-G-O-N, but I have seen septagon as well. So in case you encounter that term sometime in the future, that's what it's referring to, a 7-sided figure. Okay, so that's one that you probably need to memorize, so I would definitely star every one that you need to memorize. You probably know triangle, quadrilateral, pentagon, hexagon. Another one you're probably familiar with is an 8-sided figure. It's called an octagon. 9-sided figure, you probably need to memorize that one. It's called a nonagon. Okay, N starts with the name of the figure, N starts the word 9. Maybe that'll help you remember it. 10 is a decagon. That's a fairly common one, so you may not need to memorize it, but again, if you need to memorize it, put a star next to it. And the 11 and the 12-sided figures are based upon decagon. You're just adding a prefix to it. So for an 11-sided figure, it's called an undecagon. And a 12-sided figure is called a dodecagon. Okay. One way you can easily remember that, and you might need to memorize these, so star these, is if you think of Spanish, you think of uno and dos, the 1 and 2. It's really take off those last 2 letters, decagon, dodecagon. Maybe that'll help you memorize that. And if you keep going and going, in general, it's called an n-gon. So when I ask you about a 20-sided figure, we'll just call that a 20-gon. We'll call a 15-sided figure a 15-gon. There are terms for these, and you can look them up if you're curious. But if I ask you to write an 11-gon, I want you to use the term undecagon. So you should memorize and use the terms up to 12-sided figures. After that, 13-gon, 14-gon, 15-gon is perfectly fine. Right? So let's move on to the Polygon Sum Theorem. And the way we're going to approach it here is we're going to look at a few examples and kind of build our way up to that theorem. So you can kind of see where the equation is deriving from. The most basic kind of polygon that we have, the simplest one, is a 3-sided figure. It's called a triangle. And we already know that the angles inside of a triangle add up to 180 degrees. Okay. So what we're going to do is we're going to use that information to help figure out what do they add to in a quadrilateral. If I take these 4 angles and add them up, what do they add up to become? It's likewise in the pentagon, hexagon, so forth. Now, notice that a quadrilateral has 4 sides. And I know that the triangles add up to 180 degrees. And notice if I were to create what's called a diagonal, it's any segment that connects any 2 non-consecutive vertices. So this is considered a diagonal right here. I can create 2 triangles in that quadrilateral. This is 180 degrees. This is 180 degrees. Now notice if I look at all those angles of both those triangles, it makes up the entire interior angles of the quadrilateral. So I have 2 times 180 degrees inside that quadrilateral, which makes 360 degrees. So the sum of the angles inside of a quadrilateral is always going to be 360 degrees. So notice each polygon was going to have a different sum to their angles. Now let's look at a pentagon. Again, we can break it into triangles. And I'm going to start from the same vertex so that all the triangles start from this vertex up here. Okay. In a pentagon, I can have 3 triangles. All of them make 180 degrees. So if I take 180 degrees times it by 3, that gives me 540 degrees. So for a 5-sided figure, we have 540 degrees inside the angles of the pentagon. Again, here are all the angles of that first triangle, the angles of the second triangle, angles of the third triangle, and all of the angles of the pentagon are accounted for. Okay. So the question we have to ask ourselves now is, what is a formula I can use to find out the sum of the interior angles of just an n-gon? If you're given the number of sides. Hexagon has n would be 6 sides. Octagon, n would be 8 sides. So there should be some kind of formula I can plug into. Well, notice that as the figures increase in the number of sides, I'm multiplying by one more, or I'm adding another triangle into the figure. Okay? So the question is, how can I use this number of sides to determine how to get 180 degrees? Okay, so how do I use the 4 to get the 360 degrees? How do I use the 5 to get 540 degrees? Okay. So I go back to the triangle. There's one triangle there, so I'm going to do 1 times 180 degrees. That's kind of a basic example. But notice that this number that I'm multiplying 180 degrees by, it relates to the number of sides by being 2 less, 2 fewer. So the number of sides minus 2. So it turns out if you take however many sides you have, subtract off 2, that tells you how many triangles you have inside of your figure. And each triangle has 180 degrees in its interior angles. So to find out the sum of a polygon that has n number of sides, we use this formula. Okay, so this is what the Polygon Sum Theorem is. Okay. The sum of the interior angles of an n-gon, I'm just talking about n-gon in general because you can plug any number that for that's 3 and above, is going to be 180 degrees times n minus 2. So you take the number of sides, subtract off 2, times it by 180 degrees. Because again, that's how many triangles you can form inside of that polygon. And then each triangle is 180 degrees. So pause the video now, write down anything you need to before moving on to the examples on the back. Alright, so let's look at some examples. So the first thing we got to do to find out the sum is to know how many sides this figure has. So for number 1, and an easy way to do that is to count how many angles there are. So if there's 5 sides in this, if there's 5 angles in this picture right here for number 1, it's going to have 5 sides. So this is a pentagon. So the number of sides is going to be 5. Okay, I'm going to write the formula up at the top just so I can refer to it. 180 n minus 2. This is going to be the sum of the interior angles of an n-gon. Okay. So what I need to find out in order to solve for x is I need to find its sum. It's going to be found by 180 times 5 minus 2, because it's 5 sides in a pentagon, also known as 5 angles. So the interior sum is going to be 180 times 3, which is 540 degrees. Every pentagon is going to have that interior angle sum. So you'll start noticing you're going to have a lot of common figures you're going to be using. You're going to be using pentagons a lot. It's always 540. But it's always good to know how to find out what the sum is going to be, because I might give you a 12-sided figure. Okay, so then you have to figure that out. So make sure you know that formula. So since the sum of the interior angles is 540 degrees, I can now take all of those angles and add them up, make them equal to 540 degrees to solve for x. So I can write x plus the 81 degrees plus the 132 degrees plus the 93 degrees plus the 100 degrees all makes 540 degrees. So you just got to take your calculator, add those values up. You'll get those add up to 406 degrees Subtract off 406 from both sides to solve the equation, and we get x is 134. So x is 134 degrees for number 1. Oh. Let me write that in this little spot. 34 degrees. Alright, so let's look at number 2. We have to count the number of sides we have. So we have 1, 2, 3, 4 angles, so we have 4 sides. So this is going to be a quadrilateral. Okay. And notice, let's find the sum of the angles. Write this down. Sum is equal to 180, because n is going to be 4. It's 4 minus 2. So 180 times 2 gives us 360 degrees. So all those interior angles must add up to 360 degrees. This angle, that angle, this angle, and that angle. All add up to 360 degrees. Now, in case you forget this formula, don't forget you could always revert back upon how we created it. Find out how many triangles are in the figure. So it's 2 triangles. That's why we multiply 180 by 2. Now you got to make sure every angle has something marked on it. So we have the 98 degrees, we have 76 degrees, and we have x. And we also notice we have congruent angles, so I can put an x on this angle down here as well. So set up my equation. I have 2x's plus a 98 degree angle plus a 76 degree angle. All of those must add up to 360 degrees. You can write x plus 98 plus 76, but you can combine like terms right now if you can. Alright, so you just got to solve that equation. So 2x plus 174 is 360. Subtract off that 174, and we get is equal to 186, which means 93 is going to be the degree measure of the value of x. So x is 93 degrees. Again, pause the video now and write down anything you need to before going on to the next couple of examples. Let's look at number 3 and number 4. So again, a little more complicated now. Now what you want to make sure you're careful about is that you're using the proper angles in the diagram. This is the Polygon Sum Theorem, which talks about the interior angles, not the exterior angles, the interior angles. So notice I do in number 3 have an exterior angle of 42 degrees. That's going to be probably helpful to solve this problem. We're going to need it, but we're not going to be using that in our sum. Okay. So first, let's find out how many angles we have in here. So I have 1, 2, 3, 4, 5, and 6 angles. So in this diagram we have a hexagon, and it's going to be 6 sides. So let's find the sum of those interior angles. And again, I'm going to write the formula up at the top so we can refer to it. So there's the formula for the sum of the interior angles. 180 n minus 2. So it's going to be 180 times 6 minus 2, which is 180 times 4. When you type in your calculator, you get 720 degrees. So all these angles add up to 720 degrees inside that hexagon. Again, you're going to see a lot of hexagons, so if you memorize at 720 for a hexagon, perfectly fine. But again, keep in mind that formula in case you need to find out the sum of the interior angles of a different figure that you haven't done before. Okay. So in order to solve this, we need to have every angle marked. So looking at this diagram, I have the 120 degrees, I have the 106 degrees, I have an x, and I have 3 equal angles. So I can go ahead and put the x on the other 2 equal angles because they're all going to be the same measure. What I'm missing though is this angle up here next to the 42. So I'm going to have to do a little bit of work to find out what's missing there, and linear pair of angles, or 2 angles that form a line, must add up to 180 degrees. So if I take 42 and subtract it from 180 degrees, that gives me 138 degrees. So this angle that is not labeled is 138. The angles I'm going to add up are going to be all of the interior angles of that hexagon. So I'm not going to be including that 42 degrees in my calculations. Okay, it's just necessary to find that 138 degree angle. So adding them up, I have 3x's, so 3x plus 106 degrees plus 138 degrees plus 120 degrees. So notice I have 1, 2, 3, 4, 5, 6 angles accounted for. They're all there. They must add up to 720 degrees. Okay, so just a bunch of solving an equation to get to your final answer. So 3x plus 364 is equal to 720. Okay, subtract out the 364. So 3x is going to be 356. And divided by 3 will give us 118.6 repeating. Okay. You might end up with some decimals, and that's okay. Okay, and if you do, write the exact answer if you can. So x is going to be 118.6 repeating degrees. There's our answer. Alright, now let's look at number 4. A little more complicated because there's a lot of figures in here. I see a four-sided figure. So I see a quadrilateral, I see a triangle, I see a second triangle, this large one. Okay. So we might have to use all these, we might have to use some facts from previous lessons to solve for all these angles. When I'm looking at this, I'm first looking at this figure right here because all the interior angles are there in that four-sided figure, so it's called a quadrilateral. So we saw in the previous example at the very top of the page, number 2, that in a quadrilateral they end up adding up to 360 degrees. But again, it's not a bad idea to keep practicing that formula. So 180 times 4 minus 2, 180 times 2 means all those angles add up to 360 degrees inside that quadrilateral. Now I do see some triangles, so I might need to use those facts as well, that they add up to 180 degrees in a triangle. But for now, let's focus on the quadrilateral. I need to know A, B, C, and D. Question is, which one or more of them can I find without having to worry about the Polygon Sum Theorem? Okay, so let's look at one at a time. Let's look at A. Can I find A? Well, yes I can, because it forms a linear pair with 78. So to solve for A plus 78 is going to be 180 degrees because they form a line. So subtracting out 78 degrees, which means A is 102 degrees. Okay. So I'm going to go ahead and label the diagram. Let me erase that a little bit so I can start labeling it. 102 degrees. Because if you have to find several different angles, it might be a good idea to label what you can as you go along so you can use them to find other angles, especially if they're exact values, which 102 is exact. Okay. So there's 102. Now let's look at B. Can I solve for B? Well, if I knew what the angle next to it was, I can solve for B. And if I look at the triangle that has the 30 degrees in it, if I knew this angle right here, I could solve for that missing angle next to B. And notice it is across from 78 degrees, so I can use the vertical angle theorem to say that this angle right there in the triangle is 78 degrees, which then I can combine with the 30 to help figure out the angle next to B. So if I take the 78, add 30, that makes 108 degrees, and they add to 180 in a triangle, so I'm going to subtract it from 180, that gives me 72 degrees. So the angle next to B will be 72 degrees. Now I can solve for B by setting up an equation such as B plus 72 because they're on a line. It makes 180 degrees. So subtract out 72 from both sides, we see that B ends up being 108 degrees. Okay. I'm going to label it on my diagram. I'm also going to be labeling it in my answers. 108 degrees. Good. See how we're working our way around the figure to figure out all these angles? Okay. Now let's look at angle C. Can I figure out what that angle is? Hopefully you see it's a vertical angle with 44 degrees, so it's going to be 44 degrees. No need to solve anything there. we can know what it is just by looking at the diagram. Okay, C is going to be 44 degrees. So there's the answer. I'm going to mark the diagram. All right, now look at angle D. There's actually two ways we can solve for angle D. One is by looking at this quadrilateral. Another one is by looking at the big triangle. Okay. Polygon sum theorem, so you can choose any way you want because they're both polygons. Triangles and quadrilaterals are both polygons. I'm going to go the quadrilateral route just to practice the quadrilaterals because we've done a lot of triangle practices. So if I look at A plus B plus C plus D, that is going to be, not 180, 360 degrees in a quadrilateral. And I know A, I know B, I know C, so I'm going to plug those values in. So A is 102, B is 108, and C is 44, and then plus D is 360. So solving that equation, D plus 254 is 360 degrees. Subtracting out 254, we have 106. And there we have it. We have all four angles. Take a moment, write down anything you need to before moving on to a nice reflection for this lesson. Okay, so in general, for this lesson right here, and I'm going to create a new slide. You can see my desktop. Oh no. Okay, let's do this on here. I can't do it on here. Anyways, you can add up, you can find the sum of the interior angles by taking 180 degrees, multiplying by n minus 2, the number of sides. Okay, and this n minus 2 represents the number of triangles that you have inside the figure. So if I had a 1, 2, 3, 4, 5, 6, 7 sided figure, which is called a heptagon, I can create 1, 2, 3, 4, 5 triangles. So 180 times 7 minus 2, 180 times 5, okay, and then you can get what they add to. I believe that's 3,600 degrees. Okay. Alright, so you should be able to get your assignment now to work on that, and tomorrow I'll be able to answer any questions that you have. Thank you for watching this video. See you tomorrow.